This video will cover Year 9 Maths Applied Trigonometry Practice Test. So in here we'll cover special triangles and moving between degrees and radians. We've been focusing on special triangles, so over here this is how we form them. They are common triangles that we regularly see, and they are also ones that we'll use in methods next year in trigonometry. The other thing that forms special triangles is that they've got ratios that are nice to work with. So we form them by cutting a equilateral triangle in half, not like that. And this forms what we know as our 60, 30, 90 triangle. And so we've got ratios. If this side of the triangle here was 2, and it was an equilateral triangle, so all sides were 2, when we chopped the bottom one in half, it became 1. And through Pythagoras, we could work out that this side here would be √3 times bigger than the base. So these form ratios because trigonometry is all about ratio. So the ratios of the sides of this triangle are 1 to 2 or 1 to √3. And we usually move relative to the 1. Okay, so this way or up from the 1. We can just make a jump straight over this way, but it tends to be a bit messy, so we don't use it very often. The second one is a 45, 45, 90, and this triangle is usually formed when we chop a square in half. So what we'll end up with is a triangle that has got a 90-degree corner there, and the others are 45. Obviously, this forms an isosceles triangle, so these sides are the same, so they have a ratio of 1 to 1. And then if we use Pythagoras, we find that this has got a hypotenuse that's the square root of 2 times larger than either of those sides. Don't get confused by the surds. They have got values. We're just leaving them as surds so that the values are absolute. And if I pull this down a little bit, so we've redrawn these triangles. These are the ones to try and remember. So this is our 30, 60, 90, and the ratios that go with it. This is the 45, 45, 90, and the ratios that go with that. All right, moving on. Let's start solving these. So we've got question 1 here, and we've got a 30, 60, 90 triangle, just so that it's drawn in the same orientation as what I've done over there on the left. Remember, if we redraw this one by just rotating it 90 degrees anti-clockwise, this side would now be 12. This would be our 60-degree angle. This would be their 90. And this base here would be x. So if I put in my ratios for these, this would be a ratio of 1 to 2 based on my 30, 60, 90 triangle. And so that means that x is going to be half of 12 because this has a ratio of 1 to 2. So that means that x is going to be half of whatever 12 is. And so our answer to this one is that x is 6 centimeters. Next question. Question 2. We've got another 30, 60, 90 triangle, so we might try and draw this one as well. This one will look like this. Oops, not like that. Will look like this as well if we rotate it 90 degrees anti-clockwise. So this will be our 30, and that means that our 5 centimeters has moved to here and that our x has moved to the bottom. Feel free in the test to swivel your paper around on the desk to make these triangles line up, and just be aware that these triangles aren't drawn to scale. So that looks more like a 45, 45, 90 than a 30, 60, 90, but we've got to just use the angles to inform us. So let's put in our ratios. We've got a ratio of 1 to √3. So that means that x is going to be root 3 times smaller than 5. And this isn't a bad answer, but technically speaking, they like you to rationalize the denominator. And what that means in English is they don't like to see surds at the bottom of a fraction. So usually what they'll do is they'll get you to move those, which is why this question here has got such an unusual format here for the answer to be written in. So the way to do that is we can remove that root 3 by multiplying by root 3, but anything I do to the bottom I have to do to the top. So let's times the whole lot by root 3 on root 3, and then what we'll end up with is x equals 5 times root 3, which is 5 root 3, and root 3 times root 3 is 3. Just as a side note here, remember this is really the same as saying root 3 times root 3, and the square root eliminate one another. So this eliminates this, which is why I get this answer 3 here. So we've got our answer, which is 5 root 3 over 3. Technically, this is in centimeters as well. So here's our answer. Oops, I keep scribbling out my answers today. Here's my answer here. Question 3 is a 45, 45, 90. So I don't need to redraw this one because it's in the same orientation as what we've seen over on the left. And so we've still got this one drawn over here. So this one, if we write in our ratios, we've got a ratio of 1 to root 2 this time. And so that means that if we start to write this one out, x is going to be root 2 times smaller than 8. Again, we've landed with a surd down the bottom as the denominator. That's not ideal according to convention. So let's multiply by root 2 top and bottom. And we'll end up with the answer 8 root 2 as our final answer. Our units here should be centimeters. Okay, question 4. This one's another 45, 45, 90. This one's a reflection of the one that we drew, but the rules are still the same, you see. It's a ratio of 1 to root 2. So when we're working out x this time, x will be the square root of 2 times bigger than 5 root 2. And root 2 times root 2 makes 2, so this is 5 times 2, which is 10. So this one is 10, and the units are centimeters. We'll just tidy that one up a bit. Question 5. We've got a 60, 30, 90. And what we might need to do is we might need to rotate this one, 180 degrees. So it looks a little bit like what we're used to seeing. It will still be reflected, but that's okay. So this one will look like this. Not like that, like this. And so 60 will land down here. The x is still the hypotenuse. And this side over here will be 9 root 3. Interesting, this one. Let's have a look at the ratios. This has a ratio of 1 to 2 to root 3. And I'm going to do this one as a double stepper. I don't really want to jump straight from x over to here. Sometimes it gets confusing. So what I'm going to do is I'm going to give this a value of y, a numeral of y, and I'll work out y first. So y will be 9 root 3 divided by root 3, because y is root 3 times smaller than that side. And so these guys cancel each other out, and I'm left with the answer y is 9. Now that I've got 9, it's easy to work out x, because x is twice as big as 9, which is 18. So the answer is 18 centimeters. Question 6, we're converting from degrees to radians. So let's have a look at this one. If we've got 30 degrees that we want to turn into radians, we need to multiply this by pi on 180. And if I'm multiplying an integer like 30 with a fraction, I make it a fraction so I don't get confused, and then it's just top times top, which is 30 pi, bottom times bottom, which is 180. And then what we can do is you can use your calculator to simplify this if you like, but don't put the pi in, just put 30 over 180. What we'll be doing is the highest common factor of these is 30, so will be highest common factor is 30. So both will be getting reduced by a factor of 30. So this will become 1 pi over 6 as my final answer. Question 7. Again, I'm going from degrees to radians. So I've got 80 degrees. I'm going to multiply that by pi on 180. Make this a fraction so I don't get confused. Top times top gives me 80 pi. Bottom times bottom gives me 180. Highest common factor of these looks like it's 20. Whoops. So I'll divide both by 20, or I'll put it in my calculator, and I'll find I've got 4 pi on 9 as my final answer. Okay, question 8. Degrees to radians. This time I've got 135 degrees. Same process, multiplying by pi over 180. Make this a fraction. Top times top, 135 pi. Bottom times bottom over 180. What's the highest common factor of this? It looks like it might be 45. You don't have to write this in, I'm just writing this in to help you out. So divide both by 45, assuming you didn't have a calculator, and you'd end up with 3/4 of pi, or 3 pi on 4 is another way of saying it, as your final answer. Okay, question 9's got us going the other way. This time it's given us the radians and it wants us to convert to degrees. This is pretty easy as well. You write down your radians, and instead of multiplying it by pi on 180, you multiply it by 180 on pi. Same process, top times top gives you 180 pi. Bottom times bottom gives you 6 pi. Highest common factor here looks like it's going to be 6. 6 goes into 180 30 times. The pi's eliminate one another, so your final answer is 30 degrees. Don't forget your units, that's quite important in this question. Question 10, radians to degrees again. 5 pi on 18 this time. Multiply it by 180 over pi. If you can't remember which way to go, 180 over pi or pi over 180, the way that I remember it is when I'm trying to move to degrees here, I would like to get rid of the pi symbol. And by putting pi on the bottom, when I multiply, I know that it's going to end up cancelling itself and going away. See, it disappears. And then all I need to do is focus on the fraction. Highest common factor of 918 is 18. So this is going to give me an answer of 50 degrees. Again, you can use your calculator. Don't forget your units. Okay, question 11. A little bit longer, this one. two triangles, it's a double stepper. So in the first triangle here, we've got 30, 60, 90. So if we redraw this one by perhaps rotating it 90 degrees clockwise and redrawing it, what I've got here is I've got a 30 degrees here, I've got 5√3 here, and I need to find this line. So I'm going to give that one a value of y. So this will be a two-step one, this one. So remember, that's this triangle here. Not a great drawing, but that triangle relates to this one here. So we need to work out what y is. That's this value down here. So if we give this one our ratios, this will be a ratio of 1 to √3. So y will be the square root of 3 times smaller, the square root of 3 times smaller than 5√3. So these will cancel one another, and I'll have a value for y of 5 millimeters. Now I need to find out what x is. X is a different shaped triangle, so we'll use green for this one. So this time we've got a 45, 45, 90. Again, not a great drawing. Don't really need to manipulate this one much. It's already in pretty good position. But if we write in our ratios, we've got a ratio of 1 to √2 here. So that means that we have worked out what, we've got a ratio of 1 to √2 here instead, because we know that this side over here was y, so it's 5. That means that x is pretty easy to work out. X is 5 times √2, and that's in millimeters. Ideally, this is actually a good answer. I'm not really sure why the answer up here would like us to move a surd down to the bottom. But for the practice of doing it, if we needed to do it, it's doable. So we'll take it as a side note and we'll just say, this is a great answer. But if we were trying to put it into this format up here, I guess what we could do is we could make this over 1 and we could multiply top and bottom by √2. And that means that we'd end up with 5 times 2 over √2, which would give us 10 over √2. So I guess in the strictest of senses, if we were trying to fill out this sheet, this could become 10 over √2. But the answer that we found here is a better answer. And last question. This one's about ratio. So up until now, we've only been asked questions where we've been given angles and we are finding sides. This time we've been given sides, but we're trying to find an angle. Now this entire unit is special triangles. So if at the end of this question you get an answer that's something other than 30, 60, or 45, you have got this question wrong, okay? You could dial this straight into your calculator and get it, but for full marks, you'll need to prove that you understand what's going on here, okay? So remembering that these guys here, it has to be one of those answers. We'll move that out of the way for a minute. I also know that from mainstream, you guys know the rules SOHCAHTOA. And even though we haven't talked much about sine, cos, and tan during this topic, these are what we're comparing. That's what these ratios are on these special triangles. So if this is my reference angle, that would make this the opposite and this the hypotenuse, which means that having an opposite and a hypotenuse, I would use the sine rule. So I'd come in here and say, I know that sine theta is going to be the opposite over the hypotenuse. I know that sine theta is going to be the square root of 18 over the square root of 24. I can simplify this a little bit because 18 and 24 have the highest common factor of 6. So let's just write that down just as a side note here. You don't need to write this. And that means that sine theta is going to be equal to the square root of 3 over the square root of 4 because I've divided both of those numbers by 6. Now I can simplify this so that I end up with a ratio where sine theta equals root 3 over 2. That means that this has a value of root 3 and that this has a value of 2. And now what I need to do is think about my special triangles and think, if I draw it, in what scenario did I have a situation where this side was root 3 and this side was 2, where I'm trying to find this angle? And that, of course, happened when we built all the way over here a 30, 60, 90. So that means that wherever our question's gone, theta down here is 60 degrees. And that's our final answer, with a demonstrated working out that we understand what's happening here and that this topic's all about ratio.